The broadcast is now starting. All attendees are in listen-only mode.
All right, everybody, welcome aboard the Scanning and Modeling Complex Airport Renovation Projects webinar. This is a direct flight to our destination, faster, more accurate as-built BIM models. My name is Jason Moran. I'm the Edgewise Product Manager at ClearEdge 3D, but more importantly, I am your captain for today's flight. With me, I have Chris Scotton, the CEO and one of the founding members of ClearEdge 3D, who was humble enough to leave himself off the slide, but without him, we could not have organized such a great presentation today. Speaking today will be our panelists, Mark Hanna with PrecisionPoint and Daniel Niziolek, simulation engineer at Ramboll, UK. Before we get to our in-flight entertainment, let me go over a quick safety briefing. All participants are going to be muted during the entire presentation. That being said, I'm sure you'll have wonderful insights or witty comments to make about the presentation, and you can submit those through the questions chat box in the GoToWebinar window. Questions will be answered during the Q&A session at the end of the presentation. And of course, if for some reason you need to drop off or you're watching this later, thankfully the webinar is being recorded and you'll receive a link after the webinar is complete. Again, my name is Jason Moran, and I'm the Edgewise Product Manager. I've been with ClearEdge for a few years, and generally speaking, I'm here to make sure that Edgewise is the best product it can be, and that it's the most helpful to our customers in creating as-built 3D models from laser scan data. In my background, I'm a computer scientist and training, but aside from that, I've done a bunch of modeling projects, either here at ClearEdge 3D or in my spare time, just because that's what I find fun. Dan, do you want to go ahead and give yourself a quick introduction here?
Yeah, sure thing. So I'm Daniel Niziolek. I'm a simulation engineer at Ramboll, UK. I've been at Ramboll almost 11 years now, and my background is in product design. That's what my degree's in. I've been working with point clouds and using the data for all of those years at Ramboll, doing all sorts of modeling or calculations and using it for simulation as well. And over the last couple of years, I've started to be a major contributor to the BIM for Heritage research at Historic England. And I guess over to Mark.
Thank you, Daniel. Mark Hanna with PrecisionPoint. Been in the laser scanning industry for about 12 years. PrecisionPoint has been in existence for about 9 of those 12, and we're a reality capture solutions company doing scanning and as-built BIM modeling, and been using a lot of the tools for many, many years that we're going to talk about today. My background is in land surveying and mechanical engineering, so excited to be here.
All right. Well, without further ado here, let's get to our first presentation. Daniel, go ahead and take it away. You have control.
Okie dokie. Okay, let's see if we can move this slide on. There we go. So I'm going to talk to you today about a modelling exercise at a UK airport that we undertook. So the background to the project is that basically the client is going to demolish some of the buildings and completely renovate the rest of them, basically. So the deliverables that they wanted was a BIM model, which would become part of the record of those buildings that are being removed and the ones that are being upgraded. Full 360-degree colour photography of the whole site and the point cloud itself. And all right, so some of the challenges of this project. Well, the reason that we won the bid to survey it and to model it is because the documentation that already existed was just incomplete and not reliable. In places it would contradict each other, or there's lots of surveys over the years, but for every survey, there's another change to the site. So they needed something reliable and accurate now, as it was. Another big challenge with a site this big is just the amount of data that needed to be captured and processed and modelled. So we actually captured about 1,200 scans on site, which, as you can imagine, is a monster to process. And we'll get into that in a bit more in a minute. Another challenge is just working with an airport like this is the security and access restrictions. And how you deal with those is critical, really, which I'm sure Mark will attest to as well. And another challenge here is the requirement for working overnight in certain areas, because you can't deal with people, or you can't get access to certain areas during daytime. And if we go on again. So just quickly, I'll jump to the results of the actual modelling. So we only actually modelled a fairly small area of the airport itself using Edgewise. But of those areas, we've had at least a 50% time saving on structural stuff. On MEP, it's probably more 60, 70%. Additionally to the actual time saving, there's an accuracy improvement as well, we find, which you can start to understand if you look at the image on the screen here, which on the right, you can see this beam highlighted in green. On the left, that's a sectional view of that beam, showing all of the points used to calculate the best fit member there. Now, if I was modeling that manually in Revit, for example, I'm going to take a slice and figure out what I think the size of that member might be from a small limited data set. It's something I'm sort of making a judgment call on, and there's no sort of QA or proof or statistical analysis to go along with that. It's just my judgment call. With Edgewise here, we've actually got, using all of the data along that beam, calculating the best possible fit. And you can actually see that it's even determined the correct wall thickness of the web and flange, it looks like there. So it's pretty powerful stuff. Next, we're going to look at workflow a little bit. So for this project, we had 2 surveyors and a junior surveyor out on site. They were there for approximately 2 weeks. I think it was slightly under that, actually. And they did a couple of night shifts in there for areas that we couldn't get access during the day. In terms of the back office processing, we register all the scans in Cyclone. For this project, and nearly all of our projects actually, we use a mix of Target and Cloud to Cloud. In terms of how we process this one, so that we sort of registered regions like a floor or a building, and then we could export that to PCX and then into Edgewise and Revit, so that we could start modeling in parallel to the continuation of the registration of other areas. As I said before, we didn't model the entire airport. We modeled about 30 to 40% of it in Edgewise. A lot of that was the MEP areas. The areas that weren't modeled in Revit were mostly things that are not ideal for automated extraction, things like curtain walling, architectural columns, that sort of thing. If we go on again. So I'll just run through a few tips and best practices for you all that we found on this project. So the first thing up front there is efficient data management. I alluded to this earlier, but when you've got 1,200 scans of an airport like this, the volume of data to process just to get it into Revit and actually use that and be able to work with it is intense. So one thing we make use of on all of our projects is just make sure we're running computers 24 hours. So we've got a couple of desktop computers sat around that just process point clouds. One of the things we do here as well, another issue that you need to get around really, especially for a dual process like this going into Revit for some of the modeling and Edgewise for some of the other, is to sort out coordinate systems at the very start. And by this, I'm talking about large coordinates and how Revit deals with them. So for nearly all of our projects, we use the UK National Grid, OSGB 36 for those that care. And obviously that's got some large values in there. And if you bring that into Revit, it's going to offset it to the origin, normally by center to center. I think it likes to do it, which isn't very useful. So we tend to sort out the coordinates to begin with a simple shift in northings and eastings so that it's nearer the origin, but leave the rotation, etc., as it is and the levels as they are. And then we can just sort out the shared coordinates at the end quite easily. Typically on a project like this, we'll use the automated feature extraction, not just for things like the plant rooms, but we'll use it for complicated bits of geometry that would otherwise take a lot longer to model. Things like the truss you see here. Modeling that in Revit is, accurately at least, is a really horrible thing, because not all of those members connect nicely. They're welded joints and stuff, so they have gaps between them. They're not sort of going like a centerline model point to point, so it's all quite fiddly to model it. Whereas in Edgewise, we can model a few of these members and use the tool sets to sort of search in the point cloud for similar features. And when we're doing that, something you really want to pay attention to is the smart sheet, which I showed you a few slides back with the sectional view. The actual smart sheet itself is like a spreadsheet listing all of the parameters of that object, but it's really useful in checking the fit of each member that you get, and also using it with the I can't think what the tool's called now. Well, anyway, using it with everything you do in Edgewise, really. And I've just got a few more tips for you. So these two here are quite related to each other. So I'm going to start with the cloud-to-cloud bit here. So typically, like I said, we use targets and cloud-to-cloud. We very, very rarely just rely on cloud-to-cloud registration on our projects. For something like this airport, the way we tend to use the two in a mix is that for large areas like, say, this open area at the bottom of the screen, or the T sort of shaped corridor running through the middle, we'll put targets up through there and control those, tie them into the grid, etc. But all of these small rooms that adjoin those, we don't use control on those. That's where we use the cloud-to-cloud. So we'll put scanner in the doorway with the open door, and then a couple of scans in each room at least, and use the cloud-to-cloud to tie all of those together. And we find that is the best way to use cloud-to-cloud and targets, really, and to get the best result possible, really, in as short a time as possible. And if I jump back to the first point on the slide there, we also find that this sort of area here, with all of these small rooms, is perfect for automated feature extraction on the architectural side, so like the walls. And you might think, well, that's actually quite simple to model in Revit. You set up a floor plan and you trace off the line for the wall and whatnot. But if you actually think about the operations you need to do to get that wall accurately modeled, you have to determine what thickness it is. So you're going to end up duplicating lots of types of wall and changing the thickness parameter. You're going to have to set the levels it runs to and from. You're going to have to extend it and trim it and connect it up with other walls and so on and so forth. And you still might be thinking, well, that's actually quite simple. But if you actually look at the detail of these walls here, you've got over 10 different wall thicknesses in that area. If you look at the columns, every single one is unique. So you start adding up all of these little things, and suddenly it can take a lot longer than you would think to model an area like this. Whereas if you do it in Edgewise, the wall thickness is automatically calculated because it's got data on both sides of each wall. I've already determined what the floor level is and the level above, so it knows which heights to set as the base and top. And so it starts becoming a lot quicker to build an area like this. And coincidentally, this area was done in Edgewise. Sorry, excuse me. And I think that is the last slide.
All right, it looks like we have a few questions that have come in over the course of your presentation here, so let's go ahead and take an opportunity to answer those before jumping onto Mark's presentation. The first question, of course, is what type of scanner or scanners did you use on this project? I assume you're using Leica scanners because you're using Cyclone.
Actually, we typically use Z&F scanners. On this project, we used one Z&F, and we did use a Leica one, actually. So,
do you know which models off the top of your head?
The Z&F is a 2010C, I think it is. I'm sorry, I'm struggling to remember because we've just upgraded that one. So.
Of course.
And the Leica, I think yeah, I'm not sure on that. I can't remember now. Yeah, not sure.
All right. The second question being, what were the specs for the desktop units you were using to process the scan data? You said you were processing basically 24/7, so that was must take some serious hardware.
Not particularly, no. We've just got SSD drives in them. They're 8-core machines. Pretty, not spectacular. Sort of 64 gig of RAM, something like that. They're not over the top. Typically, for processing a point cloud, it's either RAM you need or just lots of cores. And
yeah. That and a good hard drive, definitely one of the things we encountered here doing testing on large amounts of data is that read-write speed is going to save you so much time if you're processing over the network, depending on the network speed, or over a USB connected drive. That could seriously affect your performance for even indexing a point cloud, right?
Even things like USB 3 we find is nowhere near as fast. It's not fast enough for this sort of thing. It slows it down 2-3 times. So just having it on an SSD drive locally while you process it is the way to go, we find.
I've even found that PCIe connected solid state drives are superior even to SATA connected ones. Of course, you're going to sacrifice hard drive space in that case because they're not very big yet. You certainly couldn't hold 1,200 scans on them.
Yes.
The next question is, how did you handle out of square and out of plumb elements? I guess specifically referring to the walls we were just talking about.
For this project, they weren't too concerned about that, and typically they were pretty vertical anyway. So we just left it with vertical ones. Okay. But we modeled it floor to floor, so if there was significant difference, it'd be picked up there.
Right. And I'll go ahead and plug Edgewise real quick here. When importing walls to Revit from Edgewise, you can control based on a tolerance whether they're as designed, out of plumb or out of plumb and out of square, based on a few settings for refitting the walls after you import them. So Edgewise users do have the ability to control that basically on a per wall basis. Of course, it depends on the demands of the project whether or not you do that. What resolution did we scan at for this project, Dan?
I mean, I'm not the surveyor, so I wasn't on site. So okay. I'm not sure of that sort of thing, I'm afraid.
Okay. And do you have any idea how many modeled parts per minute you produced with the Edgewise workflow?
Not
I guess
sure
a
on
rough
that one.
estimate. Okay.
I think it really would depend what's being modelled. I mean, I think it would vary quite significantly.
That's right. The piping has an automated component, so you just input the scan data, and it's going to come out with pipes after, in your case, probably a few hours of processing with 1,200 scans. Whereas certain other aspects of Edgewise are semi-automated, and you still need to extract either in small groups or individually the components.
Yeah, exactly. So things like the structure would take a little bit longer.
Yep.
But I mean, still a significant saving on that.
Yep. Do you want to elaborate on why only 30% of the work was modeled using Edgewise? You kind of hinted that some of it maybe wasn't appropriate for automated extraction. Do you want to kind of expand on what those things were?
Most of those areas, they were predominantly features that we couldn't extract automatically or were less ideal to do automatically. So there's one building had a lot of curved walls in it, for example, which is not ideal. Another one had the entire front of the building is like a curtain walling system, which was glass panels and whatnot.
Which is going to be hard to extract from scan data anywhere. You basically need to manually position that.
Exactly, yeah. There was things like architectural columns that are not standard diameter. They sort of vary a bit.
Yep.
So it's things like that.
Yep. And for the person who asked the question there, Edgewise is generally focused on elements of that are linear and of consistent size. So straight runs of piping with elbows and reducers, structural columns that are the same size throughout. So if there's something that changes size or shape over the course of its length, that's typically not something Edgewise is extracting right now, which makes it a prime candidate for modeling in another application like Revit.
Yeah, exactly. That's the sort of thing like the columns. Although with some things you might get around it, you might be able to speed up the process of manually modeling it using Edgewise still by extracting like pieces of it or something to give you a template to work to or something like that.
We have one question here that says, did I hear that Edgewise will automatically generate items like pipes and ducts from scans? Generally speaking, yes. Edgewise will, based on the scan data you give it, automatically find cylindrical objects like piping and cylindrical ducting, as well as walls in the scan data and create those for you. It does not create a 100% complete 3D model of those objects, but it can significantly increase your time or decrease the time you spend, increase your efficiency in creating those objects. Looks like we don't have any other questions right now. If there are any other questions, feel free to send them in and we'll get to them at the end of the presentation here. But for now, we are going to jump to Mark Hanna for his presentation. Let me make you the presenter here, Mark.
Great, thanks Jason, and very interesting, Daniel. You'll see some similarities here shortly. Nice to know that we're all dealing with the same challenges. So our project, our company did we've done several over the years. We've done several airport and baggage handling expansion projects, and this was one we were part of a team, a multidisciplinary team, to do the scanning and the BIM modeling. And for this particular project, it was a capacity increase within a terminal. The majority of the scanning, as you'll see here, was in the interstitial plenum space. As you may guess, very high difficulty of scanning and modeling in those confined spaces, and I'll share with you kind of the challenges my team had in both the scanning and the modeling here. The deliverables were 360 panels, a more detailed level of development, 300 for the BIM. And in our world, in the as-built world that we kind of live in here, that's it's on the high end of the spectrum. It's really kind of where we hit our limits for an as-built, in my opinion. And that model would contain architectural elements, structural, mechanical, electrical, plumbing, conduit, and fire protection, right down to actually an inch. So it was a high degree of difficulty. We were selected because we've had success in baggage handling system experience in major airports over the last number of years, and then experience in scan to BIM. And this had a really tight turnaround on the BIM model, so leveraging tools like Edgewise, feature extraction, we're really going to be paramount in meeting that commitment. So the challenges I already hit upon were that it would be up in a majority of the project up in the plenum scanning, but to add more to this, we had a very narrow window of time. Our crews only had 4 hours per overnight time period to do the scanning. We were also told, despite our best planning efforts, to be prepared for unexpected work stoppages, and I'll go into some detail on that here. Extremely complex and congested area to scan, and and I'll share with you some of the tactics the crews utilized to do that. We had a little bit of hard lid, so that was extremely difficult to even try to coordinate how we would go about doing that. And again, the deliverable had small diameter elements, particularly in the conduit. And we had these weren't terribly big areas, but they were very complex and congested in areas. And then lastly, and as Daniel indicated in his, access issues to varying rooms and areas inside of the project scope area would have different access requirements. So I'll go into a little detail there on the challenges that we're faced with there. So our workflow here for this. So I'll kind of walk through some of the field work. So the project director here staffed it with 2 scan specialists, each with a scanner. Since it was mostly plenum, one technician kind of worked below the plenum space using targeting, and then the other one, they sometimes worked in tandem with each other or worked together to kind of scan up in the plenum space and scan kind of vertically up through the plenum space. And I'll share you a little bit of detail on how they did that. They used a combination of targeting and cloud to cloud, similar to the way Daniel's team approached it for their project. So with that in mind, careful and diligent field notes would be very, very critical here. Planning and ensuring that each scan position was noted, so that in back office flow they had could understand how to put the scans together. We did have to tie into airport control and datum for this project, so we had to traverse from outside the terminal into the work area. And at the end of the presentation, I'll share with you some really unexpected challenges that brought forth to us here. The way we approached scan registration was, since we had the crews had a short number of hours to actually do the data capture, they did the registration, a course registration, immediately after their shift, so they could do a QC. And because it was so complex and congested in there, they could then on the ensuing shift on the next night, go back in and then capture more data in areas where coverage was sparse or where they needed a little bit more data coverage in those areas. So although the crews had a limited number of hours, it kind of worked out good. We made best use of their time out on the project site. Then the point cloud, also in the post-processing registration, was aligned to a coordinate system as well. Continuing on, then once everything was registered, verified for fit, and ensuring the point cloud met the tolerance requirements of the client, we then began kind of a multi-step feature extraction. So we focused on as you can kind of see, the amount of conduit, and in the lower image there, our modeling team ended up processing it through Edgewise, focusing as much as they could on completing the runs in Edgewise, connecting gaps, putting in the sweeps and the elbows and going from the conduit through mechanical. And at this stage, the smaller elements, a lot of that was everything under an inch to 3/4 of an inch, around that edge there. It did get picked up, but a lot of that finished work we ended up doing kind of further down the workflow once we got into Revit. And then we did, where possible, we did some steel extraction as well. But really our method here is do as much as we can using the feature extraction tools like Edgewise for piping and steel. Try to get those runs as complete as we can. Since we're sort of already immersed in that 3D environment using Edgewise, then we get that as near as complete as we can, and then we'll bring it into Revit to finish it out. So, and then from this stage forward, it's for this project we did all the architectural elements natively in Revit to get us the final deliverable for this client for the as build. So again, at the beginning of this, we didn't have a lot of time to. It was a pretty aggressive timeline due to the project scheduling and constraints. So we knew going in using these tools were really going to be fundamental and twofold: increasing our efficiency in the modeling side, and then also ensuring accuracy, especially with the piping elements, which is really going to be critical for the clash detection and for the new design that they were working on. So we estimate some pretty substantial time savings here in getting these models done. So it really was a success with respect to that. So not to sound cliche here, but this, as much as everybody in our industry does a great job of planning ahead and trying to expect the unexpected, in talking to the teams that were out on this job, it was other jobs like this. Each one of these is extremely unique, and this one is expect the unexpected. And I'll give you kind of some for instances here. And since we were working in baggage carousel areas, and even despite working in the overnight hours, unplanned flights were being routed over to those areas. Not everybody in the airport, and in particular the airlines, they're just kind of sending the bags to whatever carousel is available. And there were several times that the crews were actually issued a work stoppage, had to close the ceiling tiles up, and had to remove the barriers in those spaces and actually clear out of the way so that bags could be retrieved by by passengers in that area. So those got pretty stressful and hectic. Furthermore, despite all the project managing going on by all the teams there, there was a lot of things that really threw some curveballs our way. Secondly, and probably even more critical, is that we do for ensuring that our scan control and our primary survey control stays in place. We typically use stickers or hot washers. We'll glue them down in areas. We routinely try to communicate this to project management, airport authorities, cleaning crews. Hey, leave those alone if you can. We even have do not remove a sticker that says on the stickers themselves. But the crew shared with me that every single night they were losing targets. So as you can imagine, that really can put a lot of complexity into trying to recover where your scan and control positions are. So they shared with me that they hid them under rugs, trash cans, on top of vending machines. So they really had to be creative, and they left a number of extra scan control stickers around the project site. So that didn't happen. So I guess this was one of the more complicated projects that we've done where that happened. So word to the wise there. And then Daniel indicated this this as well. And we all of us in this industry deal with access issues in buildings, and sometimes this is the #1 job killer for most projects. And in this and other airport projects that we've done, the locked door access might be TSA, it might be another authority, it could be a private tenant in the airport. So we ran into, despite their best efforts, ran into a lot of locked doors, had to have multiple contacts, multiple people. We even ran into some high secure areas where the door could only be open for a very short period of time. So they had to apply scan adjacent walls, measure wall thicknesses in that short period of time in order to kind of wiggle in a scan registration inside these ancillary rooms off to the side. So that was kind of sort of unexpected. Other field challenges, when you're scanning in a plenum space, when you find it's difficult to scan wherever. You've got to kind of look for those openings and opportunities, especially when you're in the plenum. So the crews there did a lot of vertical layering of scans in order to get better coverage. Hence why it was really important to have really diligent field notes, in particular when you're doing scan cloud to cloud type registration. So and then of course you had to operate it with a tablet so you could kind of see the scanner. We were on 14-foot elevated tripods, so they needed that ability to do that. So but having that ability to retrace our steps, because then we had other people here in the office too. We didn't have necessarily the field people all the time, especially at the end of the job. Some of the data was coming in not fully registered, so someone else here in our office was finishing up some of the registrations. So really having those good notes was really paramount here for getting the scans registered. So thank you. If you have any questions, I'm happy to answer.
Yeah, it looks like we have quite a few here. Real quick, I want to jump in on people moving the scan targets. I can't take credit for this idea, but I've heard at least one story of people putting warning radioactive signs on all their targets, despite it just being a sticker or a piece of paper, which typically results in the targets being tampered with quite a bit less.
Exactly.
So that might be I don't know if that'd be an appropriate thing to do at an airport.
I will pass your recommendation down to the team.
But that may have helped you out there. All right, the first few questions are on your scanner setup here. Actually, we have one about the panoramic pictures. How did you present your 360 panoramic pictures? Were they compiled into a 3D virtual tour?
Yeah, so we used we use Faro scanners here, and we are all the panels were hosted in the WebShare cloud application for access.
All right. People are asking about the mount for the scanner and the wheels on the tripod. Where'd those come from? How do they work? I assume they know how wheels work, but
yeah. The one picture we've got a couple different varying tripod dollies, but the one in that picture that I referenced was that was fabricated by one of the scan specialists here that did that, and then the mount is actually it's an older it's a Faro accessory that mounts on a tri-brack.
All right. And what resolution was the point cloud captured at, and what was the quality set to?
Let's see, these were, I'm speculating here, usually in plenum, usually they're running, this is kind of Faro settings, so it's usually 1/8 to 1/5 with a 3x quality setting.
Mm-hmm. Now, typically for use with Edgewise, personally, I find, and you mentioned this quite a few times in your presentation, that coverage is much more important for high quality extractions than density or anything like that.
Yeah,
is that your experience?
Yeah, I would completely agree, Jason. More scans is better than less, and doing a very good job of running distance filtering to minimizing any accumulation of noises. So we run a lot of distance filtering and filtering settings to get clean the point cloud out. We get a much better extraction.
All right, that's awesome. Let's see. Do you typically follow, I suppose in Edgewise, a pipe or conduit run to the end of the run, or work the extraction in smaller sections? Basically, do you do it run by run or area by area, I guess?
I don't know how my team's doing it now, but from what I've seen recently, it's usually run by run to try to finish the runs out as much as we can.
Yep. I personally find that to be the better workflow, but certainly it depends on what's important. Yes. You want to get the highest value items modeled first, so that you're not getting down to the end of the time crunch and you still got the core part of the deliverable to do.
Yeah, if I could add here too, I think there used to years ago, there used to be a propensity to really get it, run the extraction, run the automated connections, get it done, and then get it in the Revit and finish it out. We've changed quite a bit. We spend as much time as we can in Edgewise to finish the runs and get as much modeling as we can. And I'm referencing piping a lot of times here.
Sure.
So that once it gets into Revit, it's just signing systems, cleaning up, some areas, and maybe some really smaller element things that were required to model it.
Right.
I'll just jump in here a second, just quickly if I can, because
go for it.
I actually do it the other way with the modeling in Edgewise typically with pipe runs. So I'll actually try and finish an area and work on that area first and sort of build out from there. To each his own, though, I guess. So.
Yeah, well, that's one of the things that there's always different schools of thought. When I originally joined the team here, we were very much training for kind of room by room or doing one operation to the entire facility and going back and doing the next operation until it was complete. And things have morphed around here, and our thought process has evolved, and we've grown as modelers and users here as the product has grown and we've used it more. And I personally find that run by run is a much better workflow, but it's purely a matter of preference.
I guess it also depends on the site as well. Some sites would lend themselves to different processes.
Absolutely. In a plant environment, I think it's much more important to go run by run, since a lot of cases you're going to have one large run that most other runs somehow interact with. You want to have that complete. But it certainly depends on preference and on project. I think the tools are suited for either situation. We definitely don't force that on our users one way or another. How do you deal with movable furniture, trolleys? Did the client need to move things, or did you, or how do we deal with that?
I don't know the answer to that one. Typically, in other projects, we'll move things out of the way. I know for this job it was really difficult because someone else was opening the hardwood ceilings up for us, so that was for the crew. So there was the maintenance department doing that really didn't know where to do that, so there was a little bit of they would just put it in the easiest spot for them, so might not have been the best spot to scan.
Mm-hmm. Okay.
Can I just ask a quick question, Mark?
Please do.
I was wondering how you mentioned in your presentation that it was cloud-to-cloud registration for the scans above the ceilings. I was just wondering how your strategy to get that to tie into the stuff below, and I know we've had issues with that before in places, so I was just wondering how you did it.
Yeah, so the way my team described the workflow to me is, so they're using targets below the plenum, and then as they elevate vertically into the plenum, they try to take a scan position that just kind of breaks the plane of the ceiling grid, and it's picking up some sphere targets below, and then they'll get some targets there, and then they'll move up, and then the subsequent scans, then they're just doing the scan fits. And then they're only doing scans, and they're kind of working in, if you will, vertical trees, if you will, kind of things, and registering that way.
Yeah, okay, I see what you mean. Yeah, and you're getting the first one to tie in below, and then all the others are tying into that one.
Yep. And then we use like scene, and then we're kind of creating subfolder structures within scene to keep and then using it's hard, and then we're using building those registration clusters out to make sure everything stays in place and isn't moving as you're kind of stitching all the scans onto each other.
All right. We have a few questions here about how much time was spent checking the quality of the automated extraction from Edgewise. What are your guys' experiences on that? I know I'm a little bit biased in this case.
Well, for myself, I think I even mentioned this a little bit in the presentation, but as I go through, modeling each element or looking at it, I actually go into the smart sheet and check the sectional view, and that's sort of a quick way to check anything that's extracted, really. Yeah.
What about you, Mark?
Yeah, I would agree. That's a good way to get some quick checks, and then the rest of it is just kind of more visual, just to ensure it was capped, it was extracted, and then just kind of visually looking at the fit through as it fits through the pipe, as it fits through the point cloud.
Mm-hmm.
See, another thing we quite often do with that is the clear view as well, because looking at it from the scanner position is obviously quite useful to check the fit and whatnot.
Absolutely. I think Clearview is a great tool for extracting definitely the smaller bore piping and conduit, because you have such a detailed view of that. In fact, if there's a huge bundle of conduit or anything like that, I'd put a scanner right in front of it, just knowing that you're going to use Clearview later on to model those elements. Getting a really basically high density scan of just that small section of conduit can be really incredibly helpful. From my experiences, and I'm consider myself an extremely proficient Edgewise user, so your team may be a little bit slower, but I suspect not by much. I recently did a modeling project internally where I believe we processed around 100 scans over the course of 3 or 4 hours. Each was around a gigabyte, I think, maybe a little bit less. I spent about 1 hour in the Smartsheet in what ended up being around a week or 2 weeks of modeling, doing piping and structure for an entire industrial facility. So compared to my modeling time in Edgewise, the checking of the automated extraction was incredibly small. How many modelers were on your team for this project, Mark? I guess you can go ahead and answer this too, Dan.
These weren't big areas, there were 2.
Okay.
We had 1 in Edgewise, but in total on the project there was 4 at times, mostly 3 though.
And the others would have been in Revit?
Yeah.
Okay. And did either of you put targets on the ceilings? I suppose this is in response to your difficulties keeping targets up.
I doubt it for us. I don't know those specifically.
Okay.
Again, I'm not entirely sure. I don't think they did anything like that.
But they did share with me that they were like put out target stickers were put up like on top of vending machines and high up out of line of sight or off the ground so that someone wasn't going to peel them off.
Okay. Let me see here. What's the next question? Did the project specification include positional accuracy that must be achieved? I believe you touched on this briefly, Mark, but do either of you want to elaborate on the level of accuracy that you had to get?
Yeah, I'll comment on that. It was we utilized the U.S. Institute of Building Documentation LOA standards. This job was an LOA 30, if you're familiar with that standard, which is a quarter to 5/8 relative accuracy on the point cloud, and then same on the BIM. And that was part of our proposal and accepted by the client.
I honestly can't remember what the specifications were on this one. So.
How do you handle vertical alignment if you scan only the interior? No exterior wall thickness known. I suppose this is in reference to the walls being out of plumb or out of square. In this case, out of plumb. Neither of you used Edgewise to change the plumb or square of the wall in this case, did you?
That's correct for us. We did not.
Yeah. In the case of Edgewise in general, it'll work with what you give it. If you give it incomplete data, it's going to do the best job it can with that data. So if you only give it data on one side of wall, only that data is going to be used to calculate the vertical alignment of the wall or pipe or whatever object is there. Whereas if you have data on both sides, of course, you're going to get a much more accurate and complete result. We have a question here. Why operating the scanner using a tablet was it challenging? You want to comment on that?
Well, I mean, it was. I don't know if it necessarily was challenging. It was, it's just something a little. It can get disconnected from the Wi-Fi. It's just another element that is, kind of adds some complexity. But again, when the scanner head is up in a plenum, is the only way to operate it. So, and then you're kind of it's got its pros and cons, I guess. So it's just another thing you have to deal with. Really, why I mentioned it. So.
And how many scans were you working with, Mark? I know, Dan, you said you were working with around 1,200.
These were probably in the size of these. There's a couple different areas. They were probably under 400 scans.
Mm-hmm. The next question is, were pedestrians filtered out manually? And I believe both of you were scanning at nighttime to prevent having to deal with pedestrians and your scans being crowded with travelers. Is that correct?
Yeah, as I mentioned in mine, I was informed by the crews that they, despite it being overnight, they had to put barricades up, caution tape or plastic chain and cones, work within those spaces, and then the project managers on the project site then were required to direct pedestrians around those areas, even though it was in the middle of the night. And then also unexpected flights did come in, and the requirement was to remove the barriers, close the ceiling tiles up, and vacate the area. They only had about 15 minutes to do that. So someone would come down and notify them, you've got to, those are the regulations in the airport. So.
All right. Thank you. The next question is, how much time and a percentage would you estimate that Edgewise saved you? For either of you.
For myself, it's a difficult thing to judge on this one, where we only did it on a part of the project. So it's sort of, there was certainly a significant saving, and I would say it's at least 50%, but any more accurate than that is a little bit, it's difficult to tell really, especially working on, parts of it. It makes it a lot more fiddly.
Yeah, we estimated about 65.
That's pretty good. That's about what we estimate in the marketing and sales demonstrations and things like that, and that's pretty well founded, I think. We have a comment here. For the most part, it's been my experience that the more you educate the client about the process of capturing the data, the more cooperative they have been when asked to move furniture or equipment for the site or crew. Do you guys have any comments on that?
That's definitely true, but at least what the guys have told me in the past is, like, it doesn't matter if you tell the client and communicate that to the client, because quite often it doesn't get down to the guys who are there on site at the time.
That's true. I suppose that depends on the size of the facility and what kind of business they do. Certainly, they can't.
And I would agree, but I would also add to that. Certainly, in an airport environment, there are multiple people that are responsible for certain things. So, and again, in our case, it didn't get down to the cleaning crew. So, despite sending emails and everything else, it didn't make its way out.
All right, we're at 2 o'clock now. I do want to be respectful of everyone's time here, so we're going to take just one or two more questions. The remaining questions that have not been answered, I will do my best to follow up with after the webinar. For both projects, you guys used Edgewise and Revit. Were there any other modeling tools used?
We might have used a little bit of Rhino in some areas to model a few elements.
Mark?
I'm not sure.
My understanding, no.
Okay. How did you tie into the survey points, and how far did you have to traverse to get to the project area?
I don't know how far they had to traverse into the terminal, but so our method that we use we will set we set a sticker on the floor for come out primary control, and we'll use a bipod with a sphere on it or a paddle, either way. Ensure those bipods are properly adjusted for plumbness. We're kind of anal about that here, and then we adjust for the height of the sphere, the center of the sphere, and the software to get it tied onto the control.
Okay. And one last question. This one's my personal favorite because it's the question I'm always asking our customers. What are the new features that you wish we would include in Edgewise? What's on your wish list?
One of the things for me is actually you've recently released it, which is the new E57 Direct stuff, which I'll certainly be playing around with next time.
Yeah, I'm real happy we got that in there. Splitting it was a bit of a pain. What about you, Mark?
I think for me it's a little more broad, maybe more development, but not so much feature specific. But with the increase of mobile mapping indoors, in particular, maybe for large structure or architectural, getting Edgewise to work with those systems.
Sure.
I suppose one other thing I'd add is more elements to be that are extractable. So more types of structure or more, I don't know, more features in general.
Yeah, that's what our focus is on is the automatic extraction. So we'll have to see what the future brings with that. I can't say anything quite yet. Well, that about wraps it up, everybody. Thank you for joining us, Dan, Mark. Thank you for your incredible presentations here. One last slide here. If there are any future questions, any comments, if you're interested in the Edgewise software at all, please send us any information at info@clearedge3d.com, and we'd be happy to respond. Like I said, I'll do my best to respond to all the questions here that have not been answered during the webinar. Until then, everyone have a wonderful morning, evening, or night.